So in this lecture, we're going to go over what happens if you take aldehydes and ketones and react them with sulfur nucleophiles. And if you react them with sulfur nucleophiles, they react in virtually the same way as an alcohol would react, and that's makes sense because they're right below sulfur is right below oxygen on the periodic table. So it makes sense that they would react very similarly. So if I take an aldehyde or a ketone and I react it with two equivalents of a thiol in the presence of a catalytic acid um, via the same mechanism as the oxygen as reacting with an alcohol. You replace the carbonyl with two sulfide groups here, and we call this a thioacetal. So an acetal or a thioketal if it comes from the ketone. So this is a thioacetal if this starting material is an aldehyde, a thioketal if this starting material is a ketone. And again, you can affect all of this by the Chatelier's principle. You could use an excess of the thiol and remove the water. You can also make the cyclic thioacetal or the cyclic thioketal, just like you did with the cyclic ketal or cyclic acetal. In this case, the two sulfur groups are attached by a carbon chain. So the mechanism is exactly the same for acetal and ketal formation. Now, you can one of the interesting things about these thioacetals is that they have a little more interesting reactivity compared to acetals and ketals. You can remove thioacetals in the presence of aqueous acid, so you can use them as protecting groups. But generally, when people use these sulfur nucleophiles, they're going to take those they're going to take those thioacetals and do something else with them. One of the things you can do with thioacetals is you can reduce the thioacetal to the corresponding alkane using something called Raney nickel. So in this process, this basically gets rid of the thioacetal and replaces them with two hydrogens. So it's a cousin, or it's related to the hydrogenation reaction. So this allows for a nice mild method of taking this a ketone or an aldehyde and reducing it to the corresponding alkane. And we have another way we've gone over doing that, which is the Wolff-Kishner reduction. Now this is a little bit milder than the Wolff-Kishner reduction, because in the Wolff-Kishner reduction you're using hydrazine, which is both toxic and supernucleophilic, and then you have to heat that molecule in the presence of a strong base. All right, so that's it for sulfur nucleophiles. Thanks for listening, and let me know if you have any questions.